Hey there and welcome back to the Code Wrinkles channel for a new video. And this time we'll play around with files in C#. As we will look into how we can actually work with files, especially how we can read and write files, which is a fairly common operations that we need to perform in our day-to-day tasks, mostly reading files, because that is actually something that you do very often. It could be TXT files, CSV files, or any other type of log files that are written in a text format. So let's get already started with it. Actually, writing and reading with files is not something very complicated in C#, but there are a few classes that we might have to get accustomed to it when we want to accomplish that. Now, our goal is to run this application and to simply, well, just create a new directory, create a new file in it, write something in that file, and then read out of that file and print in the console what that file contains. So as we said, the first step is to create a directory. Now, in order to do that, it's actually very easy, but we will have to provide actually a path for the new directory. And in this case, let's look first at a class that is really very useful. I cannot emphasize enough how useful this class is when you are working with files. And this is the path class. Let's have here a variable and let's call it new dir path, because this should be a path for the directory. Now, how you would be tempted to normally do this is simply specify here. We will also need to escape this, but you would like to maybe do something like C, I don't know, users. If you're on Windows, on Mac, or other operating systems, this might be probably different. However, the idea here is that this is actually not a good way to work with path files, because you can easily misspell something or mistype or don't know exactly where to put which sign and things like that. And therefore we have this path class, which is absolutely very important, because with the path class we can just simply specify some parts of the file path, and then it will construct the entire file path altogether that we need. Of course, we will also need to import this system.io, which contains basically all the classes that we need to work with files and directories. So here we have this path, and then there is the method combine. And here in this method, you could actually just provide two different strings that need to be combined, or different path portions that needs to be combined to a new directory. Now, of course, for instance, we want right now to create in the a new directory right in the directory where this application is launching. Of course, we might not know this directly where this would be, and of course also the path might be very long. So in this case, we can have here, we have this directory class, and here on this directory class we have this get current directory, which gets of course the path to the current directory where the application runs when you run it, which is fairly cool. In fact, if we just want to take a look at that, we can simply use here a console.writeLine and just put in the okay, but this is the path combine. Now let's just put here the new path, and if we run the application right now, sorry, we have a new dir path is called. Sorry for that. So let's run it again. And this time it should work, and this is actually the entire path of this new directory where it currently runs. But now we just want to create a new folder in that. So we want a new folder name. So we just can specify this would be my new folder. Of course, if we read this right now, that would be just a path string, but there is right now no folder that is called like that. So we can solve this issue very easily by simply creating the new directory. And for this, we can use once again the directory class, and we have a static method on that, which is called create directory, and we just have to specify the path for it. And this is the new dir path that we have created. So if we run the application right now, I just also want to remove this console writeLine. I don't want to print that in the console. I just want to have my application running. It runs, cool. We have the hello world, we'll also remove that. But let's take a look right now, for instance, in our newly, or in the directory where the application runs, and we see that we have here a my new folder, which is actually very cool. Now, we can run this application as many times we want, because as the folder already exists, it will always be there. So we don't have to care about that right now. Good. So then the next step is, of course, we need to create a file. But to create a file, we also need, once again, to provide a file path. So in this case, let's create a new path for the file that we want to create. So let's call this var new file, and that would be equal new file path. Let's call it, because I want to be clear about what we are trying to store in this variable, and it would be once again path.combine. But in this case, I would like to place the file that we create in the directory that we have just created. So in this case, we just have to specify here the new dir path, and then we want to specify here a name for our file. Let's call it myfile.txt. And theoretically, this should get a new path. Now, to create a file, it's actually very, very easy. It's the same as we did for directory, but instead of the directory class, we just use the file class, and on this file class we have this create static method that we can use and just specify here the new file path for that. So if we run this application right now, then this should create, once again, nothing in the console. But if we take a look here, we see in this folder that we have this my file that was created. Let's even delete it, because I want to get recreated it each time that we run this application actually. So that's it. Right now, once again, as a summary, we have created a directory, we have created a new file in that directory, and we have also learned how important it is actually to use this path class in order to set up our paths to the directories or folders and to the files that we actually want to create, so that we don't have to type long strings that would contain those. So this is actually very, very nice. However, right now I would like to write something in that file. Now here we would have to take a look at what actually this create method does. And since that it creates or overwrites, so if a file exists, it will overwrite it in the specified path, which is correct. But if we look here at the return type, we see that it actually returns a file stream. Now, this is actually what we need, because in order to work with files like reading and writing, we need a stream as a data type. And that's a very important concept when it comes to input and output operations. Whenever you need to talk or work with an input and output a target, you need, of course, a stream, because this is the most common way that we use actually to do this type of input and output operations. Now, for this one, we can here, for instance, say var file stream. Let's also type this correctly, equals file.create, and this means that we would have a file stream. Now, when it comes to this file stream, theoretically, we could already use it to write something into our newly created file. However, there is a catch here, because there are different type of streams, or actually streams that work with different type of data. There is a stream base class, of course, in C#, which is an abstract class. And then there are a lot of different implementations, actually, depending on what exactly or with which input and output target we want to work, actually. And for instance, one of those implementations is the file stream. The file stream is very important because it allows us, as it is also implied by its name, to write or read some files. However, there's a catch here, because the only way that we could do this using a file stream is using bytes or byte arrays. So this means that if we want to write some text to a file, we'd have to actually transform the text into a byte array and then write it into the file, which is, of course, okay. This is not very problematic, but it implies a little bit of more work to do. Fortunately, in C# we have two other very important classes that actually work with file streams, but that also can handle text streams. And when it comes to files, those classes are a StreamReader and a StreamWriter. And of course, as the name implies, you would use a StreamWriter if you want to write to a file, and you would use the StreamReader if you actually want to read from a file. So the first task that you want to accomplish here is to write to a file. In that case, we would, of course, need a StreamWriter. So we can say here var sw from StreamWriter equals new StreamWriter. Okay, and to the new StreamWriter, we have to specify something in the constructor. So we either specify a file path that we actually want to write to, or we can specify directly a file stream if we have it. So in this case, we already have it. So we can say here, dear StreamWriter, take my file stream and then write something to it. But of course, this just creates actually a new instance of the file stream. It doesn't actually write anything. So what we could do here is instead is, for instance, let's have a for. Let's start here with for I equals 1. We start from 1 in this case. We want to go until we arrive at 10. Let's make it less than or equal to include 10. And each time we actually iterate through this loop, what we want to do here is simply say .sw, so our StreamWriter, and then write line. And in this case, we can specify a string here, and let's also use a string interpolation for that. This is line number, and we put the I here to know exactly which line number that is. So in this case, of course, we also need to type it correctly, write line, which is like that. And that's actually it. So right now, when we run this, it should actually write to a file. Now, there is one thing that we have, however, to think about is that when we write to a file, or whenever we actually work with streams, we have to also make sure that when we don't need those streams anymore, we actually close them. So let's then here use StreamWriter.close. So this would close our entire file stream, which is actually what we also want to achieve right now. So if we run the application right now, of course, nothing is displayed in the console because we don't write anything to the console right now. So we can even close the application. But right now, if we go back here and we open this file, we see that we have all the 10 lines. So basically, we have written to this file, which is actually very, very cool. Now, okay, the next step that we would like to do is to actually read from this file, and in our case, just maybe display in the console what the contents of this file are. So in this case, we would need var sr from StreamReader equals new StreamReader. However, in our example right now, we have to be aware that we have already closed the file stream, so it is already closed. Theoretically, we could reset it, but I don't want to go into the details on how to work with streams, but instead, we could use the file path instead for that. New file path. So let's use the new file path. And in this case, it would actually read the file directly and create the stream for it. So even if we provide here a string. So the StreamReader will still work, of course. Now, what we need here, because we don't know exactly how many lines a file has, so we can have here a var read equals true, and we can simply here, for instance, have a while loop, and we say that while read. Now, what we want to do while we read? Well, that's actually very, very easy. The first thing that we could do is we can read the line. So var line, we want to read the text file once again, line by line, equals StreamReader.read line. Now, this read line, of course, will read a line for me. However, here is an important thing to note. When the StreamReader arrives at the end actually of the file and there is no other line to write, it will return null. So this is here the place where we can simply check, for instance, if line, or let's do it like this because it's a string, is null or empty. Let's do it the better way, and we say line. So if the line is null or empty, in this case, the only thing that we want to do is read equal false. So in this case, we just want to escape the loop. Otherwise, just console.writeLine, and we write the line into the console. And of course, at the end, what we also want to do is sr.close. Close that. So right now, when we run the application, it should recreate and override the file, write all the 10 lines that we have also written previously, but then also read the file and display all those lines in our console. And in fact, that's actually what happened, which is very, very, very cool. So now we know how to write to a file, and now we know how to read from a file. There are two other things that I would like to go into in this video. Now we have for now used this write line method and this read line method, but you could also write a file as a whole, so the entire file at a time. At the same way, you could read a file or all the contents of the file at the same time or in one go, so you don't have to iterate through those lines. So let's create here maybe a var sr2 equals new, create a new StreamReader instance for that, and for the new StreamReader, once again we provide the new file path, and here we could actually we don't need here a while. We could simply say here console.writeLine, and here we could just say here sr2 read to end, and that would read the content of the entire file, and that's it. And then once again sr2.close, just to close that. Good. So right now we would be able to go. What I would expect here is that in the console we would have all these contents twice, which is correct. So the first time we read those contents line by line, and here in this one we actually read them actually in one go, which is very, very, very nice. However, before we wrap this up, there is one other very important thing that I would like to cover, and to just also refactor a little bit our code here. Now, whenever you work with streams or with what we call unmanaged connections, and if you ask yourself what is an unmanaged connection, I usually always like to use this explanation. It is something, or it is a resource with which your program works and that is slower than the processor. So if you work with a resource that is slower than your processor, then you can consider that to be an unmanaged connection. Now, in our case, when you ever read from files or write to files, so whenever you perform disk operations, those are unmanaged connections. So it's good to actually really close those connections once you use them. However, closing connections might not always be that easy. In some instances, or for some other type of connections, there might be different process that needs to be performed until the connection is really closed. So to not bother on what exactly do we have to do to actually close one connection, we could use a using statement. And that is actually very, very nice, because you can have a syntax like the following. Have here using, and then you can create here what you need. And then you have this code block. And okay, so now we have here this code block with using. So we can just copy everything that we have here and move it inside this code block, which is actually very, very easy to do. And now the cool thing is we can simply remove this StreamWriter.close. We just don't need to take care about how we should close this stream anymore. Because the cool thing about this using statement is that it's actually always working with classes that implement the iDisposable interface. So we see that the StreamWriter inherits the text writer, and this implements the iDisposable interface, which has a method dispose. What this actually using does is that it performs all the job that it needs to perform, and when nothing is actually needed anymore, it knows that this is a class that implements iDisposable, so it just calls that close method or dispose method for us. And then, of course, the class itself is responsible to perform all the needed actions on what it actually means to close a connection or close a file. So this is why it's actually very, very good to use this type of using statement. And then, of course, you should do exactly the same thing for the StreamReader. Now, I would like to show you something here because it's very interesting. So we have seen here the entire using syntax, but starting with newer versions of C#, you can just simply say it this way. Just perform here, say using var sr, so no call blocks anymore. and actually it would have the exactly same effect on the entire program. It will create this instance of StreamReader, it will let it perform the job that it needs to do, but when it is not needed anymore, it will call the dispose method on the StreamReader in that case. So of course we could do exactly the same thing also here, and that should be it. Good, let's run the application once again. We see that it still works, which is great. But now we do it the right way, meaning actually that we also use this using, and this one would automatically care about disposing the objects that we actually use or disposing the unmanaged connections by calling the dispose method that these classes needs to implement as part of the contract of implementing the iDisposable interface. And if you have your own classes that kind of do the same type of operations, then you would also need to implement iDisposable and make sure that you dispose all the unmanaged connections when any consumer of your class uses actually that specific class in this using construct, which is actually very, very nice. And yeah, that's mostly it for working with files. Of course, there is one other important thing, but I really don't want to cover it in this video because reading and writing files is a process that could take a longer time when we have longer files, of course. And in that case, we would also, or it would be best also to use an async and await. But for async and await, we have a totally dedicated video, so we won't cover async and await right now. So right now, just as a summary, I just want to actually keep in mind those very, very few principles. If you work with file paths, use the path class, and most commonly you will use the combine method. So this is the very, very first important thing. The second thing is always use a StreamWriter for writing to a file and use a StreamReader to read from a file, of course. And then the third important thing is always use your StreamReaders or writers in a using construct. You can do it either with the full syntax or with the shorthand syntax. It really doesn't matter, but it really takes care about disposing and closing the stream when the job is done. So you don't have to take care about that anymore, which is a very, very good thing, I guess. Thank you very much for watching. If you enjoyed this content and if you think it was useful for you, then just please feel free and hit the thumbs up button or even the subscribe button if you are not a subscriber already, to keep actually track with all content that we create here. We do also videos and also live streams, live coding sessions, trainings, and all kind of different stuff. So if you want to be updated and always up to date when something happens here, then hitting the subscribe and the notifications button would maybe help you. And if you think that you might have colleagues or friends that might benefit from this type of content, also feel free and don't be shy to actually spread the word and share this content with them. And if you have to say something, if you have questions, or if you just want to add something here, just once again, don't be shy and use the comment section. I would be more than happy to get a discussion going here. Once again, thank you very much for watching, and until the next time, I wish you the very best.